Let's continue our conversation regarding logic by taking a look at four circuits that demonstrate each one of our logic loops. We're starting with the AND. Okay, this is a basic circuit, two switches, one light bulb. I'm using DC just because it's easier when I'm trying to explain this with the currents and stuff. So I have two switches in series. Okay, what we're basically saying is that if I close one switch, okay, nothing's going to happen. My light bulb is not going to light up. If I go close the other switch, we have a flow path for current to flow, and my light bulb's going to light up. Okay, so switch 1 and switch 2 has to be closed. So that's the principle of AND circuits. You find them a lot in safety and control circuits. Okay, now we go down to our next circuit. Our next circuit is an OR circuit. Okay, once again, I have two switches and a light bulb, but you notice that the difference in the switches is that they're in parallel. So if I close switch 1, I have a path for current to flow. Or if I close switch 2, I have a path for current to flow. Or if I close both, okay, I do have a path for current to flow. So OR, okay, still plays out here. My light bulb is still running. The next circuit is the Nand circuit. Okay, if you take a look at this circuit, okay, we have a path for electricity to flow. Okay, I have a light bulb that's lit. That's because we're going through a relay. Now, if I close switch 1 and switch 2, my light bulb goes out. So again, it's the opposite of the AND. In our first circuit we looked at, if we have an AND with both switches closed. Okay, in my last circuit we just looked at, okay, I have AND comes down if both switches are closed. Okay, let me just reopen this one. Okay. Now my NOR does the opposite of a NOR. Okay, so again, I have a 120 volt circuit here. Let me pull that out a little bit so you can see it. Okay, I have a 120 volt circuit. Let me get rid of the grid. We have electron flow, but both switches are open. If I close either switch, you notice that the light bulb goes off. That's because it's a NOR circuit. It's the opposite of a NOR. It's a negative effect. And to do this, you have to use a control relay. So again, the four circuits are the NOR, the NAND, the OR, and the AND. Okay, so that explains how the logic symbols or the words actually work in a circuit.